Hi, today we're looking at section 2-2, conditional statements. Please take something out to take notes on and write with. Complete the check it out problems at the end of each of the examples and write down any questions you have and bring them to class. Thanks.
All right, our learning targets today are I can identify, write, and analyze the truth value of conditional statements, and I can write the inverse, converse, and contrapositive of a conditional statement.
Excellent. So first, what's a conditional statement? It's a statement that can be written in the form if P then Q. And here the symbol, you can see the symbols quite a bit. Our Venn diagram, your hypothesis, which is a P part, has to be included in your conclusion, the Q part, because hypothesis, just like in science, the if part, is part of the part P of a conditional statement with the word if. Your conclusion is the part Q of a conditional statement following the word then. So it's the if-then statements.
All right, here's an example. Identify the hypothesis and conclusion of the conditional. If today is Thanksgiving, then today is Thursday. So the if part is our hypothesis. So our hypothesis is going to be if today is Thanksgiving.
Turkey day, it sounds good.
And conclusion, today is Thursday. So note, whoops, I made a mistake. I meant to make the note that today, that the if is not included in the hypothesis and the then is not included in the conclusion. So don't make that mistake that I just made. All right, next example. A number is a rational number if it is an integer. So notice things are kind of not ordered right. So the hypothesis, if a number is an integer, and make your, again, not if, a number is an integer, make your hypothesis and conclusion so it makes sense. Don't say it is an integer because we don't know what you're talking about. So a number is an integer would be your hypothesis. That means your conclusion is a number is rational. And again, don't put if or then into your hypothesis or conclusion. Okay.
Excellent. So here's your check it out. Identify the hypothesis and conclusion. A number is divisible by 3 if it is divisible by 6.
Okay, if P then Q can be written like this: if P comma Q, Q if P, P implies Q, and P only if Q. Those are very awkward. I'm sorry.
You may see them, you never know.
Many sentences without the words if and then can be written as conditionals. To do so, identify the sentences hypothesis and conclusion by figuring out which part of the statement depends on the other.
So here we want to write a conditional statement from the following. An obtuse triangle has exactly one obtuse angle. So to be an obtuse triangle, it has to have one obtuse angle. So we could say if a figure is an obtuse triangle, ooh, that's a lot of writing, then can I say it, Miss Briscoe?
There you go.
And it has exactly, just making sure, one obtuse angle.
Very nice.
A lot of writing here, people.
Just wait. Write a conditional statement from the following. So as Ms. Aiken says, the hypothesis is the innermost and the conclusion is the outermost. So a conditional would be if an animal is a blue jay, then it is a bird. And you can try it the other way and see it doesn't make sense. If an animal is a bird, it's a blue jay. You know that can't be true, so it would really need to go the other way.
Nice. So it depends on what? Your check it out. Write a conditional statement. Two angles that are complementary are acute. Good luck.
Okay, conditional statement has a truth value. It's either true or false. It is false only when the hypothesis is true and the conclusion is false. So this is really important. If your hypothesis, and this can really twist your mind around. If your hypothesis is false, then your conditional is automatically true. So to show that a conditional is false, you need to find a counterexample where the hypothesis is true and the conclusion is false.
So here we want to determine if the conditional is true, and if false, give a counterexample. So the conditional states if this month is August, the next month is September. And in this case, it is true, because if we are in the month of August, September would be the next month.
That is very true, isn't it? Determine if the conditional is true. If false, give a counterexample. If two angles are acute, then they are congruent. So two angles acute mean less than 90 degrees. Can we have two angles that are less than 90 that aren't congruent? Well, we can. The measure of angle 1 being 40 degrees, that's acute.
It is acute.
Measure of angle 2, 50 degrees, that's acute. They're not congruent. So there's my counterexample. But again, hypothesis, we can have two angles that are acute. So
It has to be true when you work that. Yep.
right, so both of these angles are acute, but they are not congruent.
And here's another one. If an even number greater than 2 is prime, then 5 plus 4 equals 8. So we're looking at that. If an even number is greater than 2 is prime, well, we know that 2 is the only even prime number. So we know our hypothesis is false. So because our hypothesis is false, we don't care about the conclusion. That means our truth value is going to be true, because our hypothesis was false. Because you can think about it, if in some case, in some far-off world somewhere, if the hypothesis was true, then the conclusion may in some sense be true too. So
Think about that for a while.
yeah, enjoy.
Okay, this is for you to do. If a number is odd, then it's divisible by 3. Determine if it's true. If not, give a counterexample.
And again, just to restate this fact, if the hypothesis is false, then the conditional statement is true regardless of the truth value of the conclusion. So that's what the example we just looked at, where it was false and the truth value was true.
Okay, the negation of a statement, P is not P, written as a tilde or squiggly. I like to call it a squiggly. The negation of a true statement is false, and the negation of a false statement is true. So it's kind of like the negative sign for conditional statements. We know if we have a negative in front of a 1, it's -1. If we put a negative in front of a -1, it's a +1. And it's the same thing. Negation of false is true. Negation of true is false.
Nice example. So here's some more terms for you. We talked conditional statements. That's written in the form if P then Q, or if then statements. From our conditional statements, we can write the converse. The converse is written by exchanging the hypothesis and the conclusion. So using our P's and Q's, it's going to be if Q then P. We just exchange those two. The inverse is a statement formed by negating the hypothesis and the conclusion. So not P, then not Q. And the contrapositive does the most moving. It uses the converse and the inverse, so it switches them both and then negates them both. So not Q, then not P.
All right, let's look at an example. We want to write the converse, inverse, contrapositive of each statement and find the truth value. If an animal is an adult insect, then it has 6 legs. So here's our P, and here's our Q. So converse, it's going to be, we're switching the front and the back. If an animal has 6 legs, and I am, whoops, I don't need that. 6 legs. I'm going to skip some words. Then
Adult insect.
it is adult insect. Is that true? If an animal has 6 legs, it's an adult insect. I don't know of any other thing that has 6 legs naturally, so that's going to be true. Okay, inverse, we're going to negate the original statement. So if an animal is not an adult insect, so if animal not adult insect, then not 6 legs, then doesn't have 6 legs.
Legs. It's a lot of writing.
I know, thanks. I got this one. I have terrible handwriting. Okay, anyway. So if an animal's not an adult insect, it doesn't have 6 legs. That also seems to be true. And then contrapositive, we're going to take our converse and make that negative. So we switch the front and the back and make it negative. So if, let's see, where are we? If an animal doesn't have 6 legs, if animal doesn't have 6 legs, then it's not an adult insect. Then not adult insect. And again, that seems to be true.
Nice. Okay, so here is your check it out. If an animal is a cat, then it has 4 paws. So you need to write the converse, inverse, and contrapositive over your conditional statement and do the truth value for each of those.
Right, related conditional statements that have the same truth value are called logically equivalent statements. So a conditional, so that's the original statement, and its contrapositive are logically equivalent. They always have the same truth value. And the converse and inverse as well. So once you know the truth value of the conditional, you know the truth value of the contrapositive. Once you know the truth value of the converse, you know the truth value of the inverse.
And just for fun and giggles, the logical equivalence of the conditional and its contrapositive is known as the law of contrapositive. You may be on Jeopardy someday, and that could win us lots of money.
And that's going to happen, I'm sure.
Sure.
All right, that's our lesson. So let's summarize. Conditional statement, if P then Q. The converse, we switch the hypothesis and conclusion, so you get if Q then P. Inverse, you make the original negative, so if not P then not Q. And contrapositive, we switch the front and the back and make them both negative. If not Q then not P. We've learned how to identify hypotheses and conclusions of conditional statements, and we also know conditional statements have a truth value, and they're only false if the hypothesis is true and the conclusion is false. So, bring any questions to class.
Thank you.